All right, this video is over stoichiometry, and stoichiometry is really dimensional analysis plus chemical equations. We're going to smash them together. And stoichiometry is never going away. Okay, it's how we solve most problems from here on out. So stoichiometry is a process used by chemists to make predictions about the quantity of the substance that react and are given off as products in chemical reactions. So basically it's all about industry. If I have this much reactants, how much product can I make, whether it's pharmaceuticals or plastics or whatnot. So stoichiometry, though, relates the reactants to products in amounts, not masses. So when we talk about amounts, we're talking about moles, right? It's an amount. So we always have to go through moles. So if you ever get confused, try to get to moles somehow, and that's the first step. Most of the time, though, however, you're provided with grams. So we'll have to be able to convert. So we have a new conversion factor. If you remember last time we made a whole list, and you need to add this one. This one's called a mole ratio. And we get this from the balanced chemical equation. These coefficients, if you remember, mean moles. So if I have 2 moles of hydrogen plus 1 mole of oxygen, I'll make 2 moles of water. And you can relate those quantities to each other. These are your mole ratios. All right, so up here I have a little pathway. And sometimes you use parts of the pathway, sometimes you use the whole pathway. But if you notice, to convert between substances, you always have to use your mole ratio from your balanced chemical equation. All right, so we're going from mole to mole. These are one-step problems. How many moles of ammonia are produced when 2.5 moles of nitrogen are consumed? So you're going to start with what they gave you. They gave you 2.5 moles of nitrogen, and y'all need to start writing your compounds because we're going to switch between compounds now. So I want to go from moles of nitrogen to moles of ammonia. So I look back at my balanced equation. For every 1 mole of nitrogen, and that's going to go on the bottom, I have 2 moles of ammonia. That goes on top. Multiply across, so 5 moles of ammonia. And really with sig figs, you'd point 5.0 moles of ammonia. Okay. How many moles of hydrogen are used if 1.5 moles of ammonia are produced? So again, start with what they give you, 1.50 moles of ammonia. And from my equation, I know if I have 2 moles of ammonia, I've used 3 moles of hydrogen gas. So 2 moles of ammonia, 3 moles of hydrogen gas. So 1.5 times 3 divided by 2, that is 2.25 moles of hydrogen gas. And I get 1.7 with sig figs. Mole ammonia. That's a period. Okay, how many grams of nitrogen are used if 15 moles of ammonia are produced? Start with what they give you. 15 moles of ammonia. So now I'm starting with moles. So I can go straight to my mole ratio. So for every 2 moles of ammonia, and what am I trying to get to? Nitrogen. So I have 1 mole of nitrogen, but they want grams. So I got to keep going. For every 1 mole of nitrogen, it's 28.02, I think. I hope. And so with sig figs, 3, I guess it'd be 210 grams of nitrogen. All right, mass to mass. These are the longest ones. We're going to use this whole pathway. How many grams of ammonia are produced when 10 grams of hydrogen are consumed? So start with 10 grams of hydrogen. And I have to go through moles, so I got to convert this using molar mass. 2.02 grams, 1 mole. Then from my equation, I know for every 3 moles of hydrogen, I make 2 moles of ammonia. And then they want grams. So 1 mole of ammonia, 17.04 grams. And that gets me, yikes, with sig figs, I guess it'd be 60. I got 56.24. So since sig figs, yeah, I guess I'd round to 60. 60 grams of ammonia. All right, try these problems. We'll check them in class.